Hello everyone, welcome to part 5 of how to create a horror game. By now you're pretty advanced in 3ds Max and know many techniques. We are about to start rigging the character, but before you start it we have to understand a couple of fundamental things. Today's lesson is going to be quite advanced. You can see the topics on your screen. Some of you might know already about this, some of you will not. If you don't know it, do not worry, simply make sure that you've watched first 4 parts. Ensure that you learn them well and come back here, because today's lesson is going to be quite advanced. You need to know the basics of 3ds Max in order to be working with me. Also, we've covered ZBrush in previous lessons, and so it will be a good bonus for you if you watch it. I'm very happy to tell you that in this lesson we are completing our core for texturing. That is, having finished watching this lesson, you're definitely going to be familiar with strategies that artists take during this stage. My name is Igor Aherne, and by the time I'm writing this tutorial, it's almost Christmas and almost New Year. I want to thank everybody for your interest and support. I really appreciate that you like it, I enjoy reading the comments, and as well when people are asking me questions, it's also very interesting to answer them and think about them. Thank you very much for your support, Merry Christmas and Happy New Year. Let's get started. As well as shaping out the look of your model, you need to ensure that the smoothing on the polygons is nice, so that you trick the user into thinking that the surface is actually smooth, with a basic shader interpretation that you don't even need to worry about. 3ds Max will do everything for you with the smoothing groups. So really quickly and efficiently, I would like to explain to you how you can use them. If I click on this object, right click and hide unselected, press Z to center on it, you can see that it's some kind of cavity for the eye of the robotic character. I want to make it look round and smooth on this area, which is like an arc, and then the bottom arc as well. And then I should have a sharp connection over here, sharp edge here, and a circular sharp edge around the cavity, as well as inside. To do this, I'll need to set up several of the smoothing groups. If I press 4 in the editable poly object, I can select everything, go down, maybe close down any kind of rollouts that I don't need, so that I can jump back and forth quicker. Let's grab polygon smoothing groups and drag them up, because that's the one we'll be using. Control A everything, and assign a smoothing group of 1. If we press F2 now, or deselect anything just by clicking in the empty area, but F2 in my case, you can see that the smoothing is applied to the whole mesh altogether, and it kind of looks organic and perhaps round on the edges, whereas actually it isn't. And this is just a trick of shader on your eyes, because the model is really sharp if you look around like this in the edged mode. However, if you turn it off, you'll be tricked once again into thinking that it's round. Really, we need to set up some of the smoothing groups, because right now everything is smoothing group number 1. And if we select the faces on the side, maybe grow, we can then assign a smoothing group number 2 and deselect smoothing group number 1. There should be also a straight edge around here, and especially over here. So this is smoothing group number 1, this is number 2, this one should be number 3. To quickly select a ring or a loop in edges or polygons, simply click on one of your wanted ones, hold shift and click on the neighbor, and you got yourself a nice selection. Then select the remaining ones. If you click ignore backfacing, you can scrub through the selection mode by pressing Q, or simply click and hold and select the needed one. I usually prefer working with this one, so you can click on here, and with ignore backfacing, simply carefully select the wanted ones like so, and then drag out like this, and alt left click any kind of remaining ones. Then, you guessed it, let's assign a smoothing group number 3. After this, observe the changes. Perhaps do something for the back, but we're not going to be doing it right now, because you already got the idea. Maybe do something for the inside really quickly, like this. Deselect smoothing group number 1 and select smoothing group number 4, or 2, because it's not touching group number 2. Finally, a very important idea to understand is that you can create a smooth transition. So for example, you can create a smooth interpretation so that they are flowing into each other nicely, and then this kind of edge emerges from here and starts to become sharp as it goes over here. To do this, let's see, this is smoothing group number 1, and this is smoothing group number 2. As well as that, if we select smoothing group number 1 and smoothing group number 2, you will see that those buttons are actually empty. That means that some of the polygons are of group number 2, Some of the polygons are of group number 1. We don't know which ones. We can actually cancel their groups by simply clicking here and then deselecting and clicking once again and deselecting as well. We can click on the empty space to observe the changes, and you can see that there is no shading on the polygons at the moment. So let's restore our work. 1 over here and 2 over here. We want to create a smooth transition from right to left. This is number 1, this is number 2. And it really doesn't matter in my case from which side I want to create the transition. Let's say, for example, this side. Let's select the polygon and apply smoothing group of number 1 as well as number 2. As you can see, now this polygon blends nicely with the neighbor group number 1. However, its neighbors of group 2 as well don't blend with the group number 1, which is at the bottom, as we go further on. If we want to, we can extend this transition by selecting the neighbor and also applying group number 1, so that it has number 2, blends in with those number 2s, but also blends in with number 1s. It is always possible to select by smoothing groups. It can simplify your workflow very nicely. So for example, select by smoothing group number 2. And we see that this is the top arc. We can then go into edit polygons, inset, or do anything you want to. If you are really lazy, which is pretty bad, but if you are, you can press Ctrl A and simply auto smooth everything you want to. You can increase or decrease the threshold of angle. If you decrease it, you're gonna have sharper angles, and if you increase it, your model is gonna be looking smoother because the breaking point is gonna be greater, will be requiring greater angle for applying a new smoothing group. Never forget that you can use soft selection while working in editable poly. Just follow the principle of third tutorial when we were working with a cage for projection in our third part. And never forget that you can be using local, world, and it's always going to be changing the axis that you're working with, always altering the point from which you'll be scaling, rotating, etc. So this slider is very useful, and also here you'll be using first option to stick your axis to the pivot point, or this one to stick it in the middle of selection. There is a very good addition to the technique I've explained to you in the previous tutorial, that is with the unwrap UVW. The trick is, you don't have to move the points for the second half of the model you are unwrapping. It can be done using symmetry. But this implies that your model will be totally symmetrical. In order to use this technique, you only need to produce one half of the model. To illustrate this case, let's import the model of my mechanical eyes into our scene. And straight away after importing the model, you can see that the polygons are flipped in a very strange way. That is the problem with their smoothing groups. This happens sometimes when importing models from different versions of Max, and to get rid of this problem you simply need to select an object, make sure it's in editable poly, or right click and convert to editable poly, press 4 Ctrl A and simply detach your selection under a new name. As you can see, I was right, the problem was in smoothing groups. And so I will repeat the process for other 3 parts right now. However, after detaching your parts, the editable poly still stays there, so the empty one should be deleted. Press H, find it somewhere in your hierarchy. In my case, it's those 3 ones or 4 ones. Let's click on the first one, Shift, click on this one. After this, delete, and you got yourselves a new renewed model. Mine consists of 4 parts. This is a front part of the socket for the eyes of the robot. And if I zoom out, you can see that it rotates around this point. And it should be parented to this part, which in turn should be parented here. And this one should be parented over here. So this is the main parent, rotating which will rotate everything else. And for example, rotating this will rotate only the further 2 parts. So it's quite flexible. It's like wormy eyes of the character. But the point of this example was to show how you can use symmetry to simplify the process explained in the previous tutorial. Let's do it by examining this part. To illustrate the case, let's simulate the situation by removing one half of my model. Let's just check that I've deleted it nicely. Yes, I did. Go out of editable poly and apply a modifier unwrap UVW. In my case, I've already unwrapped the model before, so its UV coordinates are already sorted out and were stored in the history of the model. That way I don't have to worry about setting up the seams at the moment, because they're already there. If I open up my UV editor, you can see that the model is unfolded somewhere here in the corner. This is exactly one half of my model. As promised before, if we will put symmetry on this model, that way reflected, The UV coordinates will still be over here for the second part as well, simplifying greatly the task of adjusting those vertices so that they fit perfectly together. They will already be set for you and you won't have to worry about sorting them out. Let's close the edit UVs, and we can either right click on this modifier and collapse all, or if you have several modals, for example, that have unwrap UVWs, reset X forms on them, the easiest way to collapse all is to simply select all the modals and right click and convert to poly. This will ensure that all the modifiers are removed and are stored in the history of your model. Let's examine this model slightly further. You can see that the pivot point is right on this edge over there. And so with this model selected, if we apply symmetry modifier to it, the mirror is going to be positioned where the pivot point at the moment is. We can expand it, select the mirror, and always adjust it if we want to. We can flip it and maybe mirror it along the different axes, but right now it's X and it's perfect. Maybe increase the threshold, but watch out so that the vertices are stitched correctly and you're not overdoing this, for example like this. Just keep it low and make sure all the vertices on the sides are stitched together. In my case 0.2 will be fine. Then you can right click and collapse all, or in my case just convert to editable poly, which is exactly the same thing. After this, let's quickly check what we've done so far. Unwrap UVW, open UV editor, and you can see if I turn off my show map, you can see that the parts are perfectly aligned together. If I pull this polygon, for example, to the left, you can see that there is one part lying underneath it. So keep it there, and you just saved yourself so much time. Of course, if you are projecting normals from the higher representation of the model, you might want to select one half of your model with ignore backface deselected, so that you can select everything all together, and just check that you have a nice selection. And as explained in the first tutorial, simply move it by one UV space with this button pressed to the right or to the left, doesn't matter, maybe upwards using V. And it's going to be over here, sampling from exactly the same area of the texture, just shifted by one unit space. If after finishing the fixing of unwrap UVW on your model, if you found out that the model still requires some further adjustments, for example there is some kind of strange hole in the model, in my case I should have been drunk not to notice this, but if there is some kind of problem like this, but you've already adjusted your unwrap UVW, you of course know that you can't jump into editable poly and fix this hole by connecting or bridging whatever, because with the unwrap UVW modifier on top of that, you would simply destroy your work, forcing you to go and load the safe version of unwrap UVW. And for example, if I apply the checker material onto the model, you can see that there is a hole in the model and there is a need to fix it. In order to do this, you just need to collapse all the stacks or simply right click and convert to editable poly. That way all of the UV coordinates are baked into the model. And you can simply select two edges and bridge them if needed. And cap the last thing over here. Of course, you'll have to adjust the UV layout on those parts as well. To do this, you have to deselect everything else, go into modifier list, and once again go into unwrap UVW, open your UV editor, select those 4 polygons, and maybe let's do a planar projection on them. So the square gizmo you see over here is a simple representation of the screen of the UV layout table. Press R, go into local from the pivot point over here, and let's scale it out like this, and notice the changes that happen over here. This is simply the relation of the gizmo to the parts that we're projecting. Of course, the checker is too small. That means that the part is taking a great portion of the texture on our table. So if we increase the proportion of the screen, that is the gizmo, by scaling it up, that means that the part is going to be taking less space. You can see it shrinking down as I expand our gizmo. You can see our part shrinking down in our UV layout table. Let's scale it up so that the checker is exactly the same size, or at least similar to the surrounding areas, like so, and deselect the planar selection. Let's move it down for now, and we need to identify to which part it belongs to. So we need to select the surrounding polygons. Clearly it's over here, and so our part should go to the right, like this. Well, in my case it's a perfect fit, but sometimes you need to improvise and position your parts so that they stick correctly and don't interfere with their neighbors. In my case it's a perfect fit, and we can position it like so. Right click, flip horizontal, position it in place, press 1, go into the vertices, go into tools, or simply right click and select target weld and drag your vertices onto the required ones. With this approach you already know how to save your time twice. Now it is clear how to hotfix any kind of problems after you've done your unwrap UVW. If you are really determined to become a pro in 3ds Max, you want to consider using the shortcuts, since using them will increase your performance and speed, will take the need of right-clicking or scanning through the menu off your shoulders, because you'll be having a quick access to those actions on your keyboard. To do this, we need to go into Customize, Customize User Interface, and there is a very basic set of instructions that I'm using at the moment, or hotkeys, for when working with editable poly. You can set up different ones for unwrapping UVW, for example, or any kind of different actions you want to perform on your model. The options we're looking for hide in the keyboard, editable poly. Within this list there are about 6 essential hotkeys that you need to work with. First one is of course connect, the one that connects two edges once you selected them. And if you look, there are actually 2 options, connect and connect edge settings. Always go for settings, because that way when you press in your hotkey, a window will pop up that will allow you to connect with multiple edges and actually spread them out, maybe slide them to the side. Whereas if you select connect, that means that you'll have to click and drag between the edges to connect them with different edges, and it won't really give you as much flexibility as the settings would. The shortcut I'm using for connect edge settings is Shift D, and it's not assigned to anything, so let's click assign. And the next option that should bring your attention is grow. Press G on the list. Grow selection simply expands the selection from the selected face. Let's look for extrude, and we got extrude mode or extrude settings. Right now we got Shift E on extrude mode, and instead let's use Shift E on extrude settings. So select extrude settings and press Shift E. Assign. We also need to set up the inset, and from it let's not select inset mode but inset settings. Press Shift F and assign it to it. After that let's do inset vertex mode, Shift V. And in further levels of your skill you might want to consider using ignore backfacing in selection. However, for now let's omit it. Finally, let's do target weld, which is at the bottom of the list. Target weld mode, there is no settings so far. Hotkey Shift W, assign. Close the window and you got your shortkeys ready. Let's test them out on this model over here. If we go into polygon mode, pressing 4, deleting this polygon. If we press 1 and press Shift W, we can now target weld the vertices with our shortcut. We can press 4 and select this polygon, press Shift F, and with our settings inset the polygon by the required amount. And by the way, if you press Alt, you'll be insetting by a smaller amount, and if you press Control, your spinner will spin quicker. That's a nice tip as well. You can inset several times or accept it. That's the pleasure of having the settings in front of you, rather than going to inset mode and just manually dragging onto the polygons. So you can do it several times, like twice for example. And then press OK. You can then press Shift E and using our shortcut, extrude inside or outwards your polygon. With the selection mode of crossing, let's press 2 and go into the edge mode. Press Q to scrub through the selection modes. This one is my favorite because it allows to create a very nice selection set, very flexible one. I'm always working with it. You can go and select your edges by just scrubbing through them and release. Then press Shift D and you got yourself a nice selection ring. Of course, make sure that ignore backfacing is not turned on, otherwise the back ones won't be selected. Press OK, or actually, because you got settings, and this is very nice once again, you can adjust the number of segments you want to connect with straight away. You can increase the pinching, or you can slide them left and right in any way your heart desires. Confirm the change, and for example, if we want to scale out from the center, we would go into the scale from center, not from the pivot, which is the first one, but the second one. Press R, and you have to do it once again, and you can scale them out and create this round shape of the model, or actually a bent inwards. However, then you need to adjust your edges so that the model flows nicely, like so. Maybe change your interpretation of axis to world. Press Z to center and then scale out. Clearly there is a problem because there is an unused vertex, which simply breaks the potential edge into 2 parts. So we can select it and press backspace to get rid of it. And then maybe press Shift W while being in vertex mode and click and drag and target weld. If you haven't applied your unwrap UVW so far, you can simply adjust one of the parts and then remove one half and just put a symmetry modifier just to duplicate the left part to the right side. You don't have to readjust the right side and spend your time on doing work that could be done with the modifier in seconds. Let's quickly get rid of this half. Press 3, select the border, and either press R and scale it in the x-axis in my case to flatten it out, or press Ctrl and click on the vertex editing mode to preserve this selection but convert it into the vertices, and click Make Planar in X. A very good shortcut of getting out of any mode is not to scroll up and then deselect, but to simply press 6. Now when projecting the normals, they will go onto the left part, and the right part won't be considered at all. But the right part will be allowed to sample from the exact area of the texture, which is over here. For more detailed explanation of normal mapping, please refer to part 3 or part 4, which is a nice extension to it. That way we've really quickly fixed any kind of changes to the left side done in editable poly, and we've also readjusted the unwrapping VW really quickly so that the projection falls nicely when doing our normal mapping. If you want to, you can right click and collapse the stack by converting to editable poly. Or of course, if you have a shortcut for it, you can simply press the shortcut. Very important notice is that your keyboard combinations won't be working unless this button is pressed. This is a toggle. So for example, Shift F is usually a toggle for safe frames on the camera, which simply represent the aspect ratio that you are going to be doing when rendering your final movie. If you are specializing in that area, not in gaming, you can press here or press F10 and simply change the resolution for your camera by dragging the slider like so, and you can see that the viewport is showing what is going to be rendered actually, and of course not showing what's behind the borders. To render in the ratio of my viewport, it would have to be somewhere here, something like this. Once again, never forget to do the smoothing groups for your polygons. Make sure your mesh is modeled properly, there are no holes in geometry, so press 3 and Ctrl A to see if there are any kind of gaps to be filled. If there aren't, great. You can also go into modifier list and press S and go into STL check and check for open edges, that is holes, double faces, spikes, multiple edges where there are vertices breaking the edges into two halves, or everything straight away. Then press select faces, and if you click on check, this is going to be selecting all the faces which have problematic areas next to them, or the edges for example. Or if for some reason you don't want to, you can choose don't select and it won't be doing anything. In my case, I have a clean model right here. You can also go into views, X view, open edges, multiple edges, isolated vertices, overlapping vertices, which is a quite common problem, at least in my case, and fix any problems from there on, because the overlapping vertices will be highlighted with green, like here for example. If I press Alt Q, this is a shortcut for isolation, and isolation can be turned off by pressing on this bulb, but it's a very quick shortcut just to see what's around the model, especially if it's in crowded area. So Alt Q, and you can see that I have 4 overlapping vertices. We can go into editable poly and check closely those vertices. Perhaps they will require target welding, so we can click here, move it to the side, and you see that actually there is a face break here. So all we need to do is not to move it too much, but select this one, press our handy shortcut with this button pressed on, otherwise the shortcuts won't be working simply. Press Shift W and drag it here. Same for this part. This is a vertex that is very strange. If we select it, move it to the side, there you go. Another problem has to be fixed. Boom, done. And finally one over here. Also move it to the right. Here you go, I got you, buddy. And although it said that there are 2 vertices remaining, when we click there is going to be 0 vertices because the last 2 were obviously over here. Watch out, because if you click your tolerance to be too high by clicking here and setting it up too much, you may see that you may force it to think that the overlapping vertices are any ones between which there is this distance. So for example, if we put it too high, like 3, if we go out of any editing mode, you can see that it interprets the overlapping of vertices just as we would expect it to be. To get rid of this message, go into Views, X View, and deselect overlapping vertices. If somehow you find out that the overlapping vertex is inside of the model somehow, and you don't know how to access it because it's not on the surface, you can select the model and press Alt X. This will put you into the X-ray mode, and you can actually trace down the polygon or the vertex that you're looking for, maybe target welded. Finally, this is the way I'm trying to work right now. I'm mastering the shortcuts, but I also want to free my space. I really want to work in an area that is maximized for me and is not crowded. I don't want to see any kind of options that I'm not going to be using. I already know my shortcuts, I already know the editing regimes, 1, 2, 3, 4, 5. I definitely know that I'm not going to be using the timeline because right now I'm not animating. So it would be nice to create some kind of buttons that would be triggering off this bottom area over here. If we press Ctrl X, that is going to put us into the expert mode, the one that expects the user to be working with shortcuts. However, we still have this timeline. So if we press Ctrl X or simply cancel the expert mode, we really need to come out with a way to get rid of this timeline. But one more thing before that, I want to mention that in 3ds Max 2014 there is a quite annoying toolbar that some people don't notice or maybe don't know how to get rid of, which is I think pretty straightforward. Simply grab it by this area and drag it to the side and close it. You can always restore it by right-clicking in this area and clicking Viewport Layout tabs, and you can dock it if you need to. In my case, I definitely don't require it, and what I really want to do now is to get rid of the track bar, and this is where we will touch slightly the macros for 3ds Max. Those are the simple commands for 3ds Max that can be put into the listener window, and we'll do something with the interface. This is the area that we'll be working with. We can put our commands over here, but the window is really small, so let's right click and open listener window, which is a maximized version of this window. To see the red part, the input part, it is required for us to click here and drag down the border. This is where the 3ds Max will be communicating with us, and this is the area with which we'll be talking to 3ds Max. To hide the track bar, all you need to do is write in the red area track bar visible equals off. Straight away observe the result. Finally, we need to get rid of this slider, which is called time slider dot, and let's call a function called set visible off. The way to get it back would be to simply put on instead of off, and if we close this window for now, press Ctrl X, you see that we've freed up our space by such a great amount. Press Ctrl X to get back again, and it would be really nice to simplify it even further by creating two buttons to simply trigger this change in interface when we interact with it. To do this, let's open our window once again by right-clicking opening listener window, and we go into customize user interface. We've been working with keyboards before. Right now we need to go into toolbars. Let's click new time hide. Press OK. This is our toolbar, quite similar to the one present in 3ds Max 2014, which sticks to the side, but we really need it to be small, so let's put it here. This is the place where we'll be putting our buttons. All we need to do is simply select this text and drag it into the area, and this created ourselves a nice button. Also, let's create another one with simply substituting on. Once again, select the text and drag it to the side. We can then dock our time hide somewhere here, for example. Maybe let's right click it and edit button appearance. Choose the desired section with simply clicking here and scrolling up and down. Find something you like. Don't forget that you can also scroll through those areas if there is something in here. In my case, for the tooltip, I'll put hide the timeline, maybe use a stop sign like this. And for this one, right click, edit button appearance, find something similar if I manage to. Tooltip, show the timeline. And now we can hide it and show it. It doesn't matter, I've messed up the tooltips and the images, but it works. So we can right click and change the button appearance to be of the desired one. And it's working perfectly. This is a very nice way to interact with interface. You can research more about this listener window and find out different ways to interact with your interface to make it even more useful. Let's close our customize window. We've already worked in it with the keyboard shortcuts, and we've already worked with the toolbars to set up our own buttons. We can hide our timeline, press Ctrl X, and maybe work with our object further on. If I get out of the expert mode to show you what I mean, Like explained in the very first tutorial, there are different constraints within which you can work with your vertices and edges. There is no constraints, edge constraints, face and normal, but usually we work between none and edge. If we select edge, if we try to move this vertex like this, it's going to be sliding along the edges like so, trying to preserve the volume of the object and not deform it. Whereas if it's in none, if we try to drag it like so, it's going to be deforming freely. Depends what you want. You might find that the model doesn't extrude the polygons correctly within the edge regime, but it will do nicely in none. However, edge is very nice when you need to preserve the geometry. And of course developers thought of this and already created a shortcut for you, which is Shift X. So by pressing Shift X, you're going to be switching between edge and so Shift X, sliding along the edges, Shift X once again, and free deformation. Make sure that you press your hotkeys quickly, because if you don't do this, you might actually find yourself jumping back and forth as the 3ds Max tries to figure out what you're trying to achieve by holding this combination. So press quickly on the hotkeys. As I said before, you can press 6 and get out of any editing regime. Studying 3ds Max for quite a long time made me realize that 3ds Max is something more complex than just drawing different kind of models, creating objects from different polygons, animating or texturing them. When you take a deeper look, you'll understand that there are some things that are behind the scenes. There are processes that usual users or beginners might not have a clue even about, but in this tutorial I would like to show you some of them. Of course, you know the basic principles of 3D. Objects consist of vertices, which are connected by edges, and between edges you see polygons. But of course there are different variables other than that, which are rotations, positions, scales, basically the variables that control those parameters. So far we've been looking at several of those panels, mainly at create, modify, or hierarchy. But as we go further on, I would like to explain to you what other panels mean. If we go into motion, you can see that if I select an object, you get all of those different parameters that might scare a beginner, but really they are a simple tool for working with objects. Before we advance further, you have to understand what is a transform. Transform is a property of an object which controls position, scale, and rotation. And you can see it if you go into the fourth panel called motion, if you open up assign controller, of course with your model selected. If you open up the transform list, you can see that it contains position, rotation, and scale. Our transform is of type position, rotation, scale. Our position is of type position XYZ, rotation is in terms of Euler XYZ, and scale is a Bezier scale. We can always change the type of those parameters, position or rotation for example, by assigning a different controller, different from Bezier. Right now it's over here, but we can go for anything we would like, and then this would affect the behavior of an object respectively. But let's step away for a moment and close this rollout. If we get back to the hierarchy tab, so far we've been working in pivot fold, but there are two more of them. You are familiar with the just pivot rollout in pivots panel. You can affect pivot only and then modify its rotation whatever you want. Change the forward direction or how it's interpreted within the object by rotating your pivot point, or you can even change the pivot's point position, and then the object's transform is going to be calculated from there. While doing affect pivot only, you can always align to object or align to world. And if you have a look over here, if I bring the camera over here, if I rotate it, you can see that there are three axes. The world axis shown in the bottom lower corner on the left. Z is looking upwards at this position of camera, of viewport. Y is looking to the left, and X is looking kind of diagonally forward over there. If I rotate the camera, you can see those arrows changing. And in fact, they are exact representations of a world's transform gizmo axis. Z is looking upwards, X is looking to the left, and Y is looking towards you. Exactly the same as on the left. If you switch to local, your transform gizmos will fit those ones of a pivot of an object. So what I was saying is that you can align to world, and your pivot point will be aligned to the axis displayed over here. Your local representation will be exactly the same whether you are in local or the world representation. If I get out of this pivot point only, I made it so that you can't move the object anywhere, and if I go into local, the axis will disappear because I've locked them. You can lock those variables of type transform, of position or rotation or even scale by going into link info, and checking those boxes. If I uncheck Y, for example, you can see that the arrow appears, meaning that I'm allowed to drag the object left and right along the Y axis. And of course, because I'm in local, that means that the Y axis of pivot point is looking exactly over here. If I go back into world, you can see that Y axis is looking towards here as well, even in world representation, because I've aligned the pivot point of the object to suit of the axis of the world. But for now, I'd like to stay in a local representation, and I'm viewed only Y axis because that's the one I've unlocked. If I lock it back again, I won't be able to move it anywhere, but I can rotate the object in any direction, and I might want to restrict it, so I can lock all the axes, and you can see that I'm no longer able to rotate the object. I can try to, but it won't respond. And in fact, in local, the axis will disappear, or the gizmo will disappear, and I won't be able to rotate it. I've also restricted it in terms of scaling, so you can't scale it in any direction. If I uncheck Y, for example, and go into scaling, if I'll be scaling up, it will be always scaling only in Y axis. We will get more familiar with the middle rollout as we do the rig for the character, but for now let's leave it aside, because this is the rollout for tweaking our IK solver settings. If we get into pivot, this is how you usually see this panel once you open hierarchy, so we're back again. Once again, we return back to our transform position parameter, which if we open it contains three other parameters: position of type position XYZ, rotation of type Euler XYZ, and scale Bezier scale. If we drill down to position, you can see that all of my position parameters are of type Bezier float. That means that if they aren't locked on our hierarchy panel over there, if they aren't locked, you can actually move the object around freely. And also the same thing happens for rotation as well. We can rotate it freely unless we've locked the rotation. And for now, I would like to open up the X rotation so that we can rotate it around the X axis. If I switch to this object, which is a bar, you'll see that I can't move it left and right. But if we open up our hierarchy panel and go into link info, you'll see that the parameters aren't actually locked, and I should be able to move them, but I can't for some reason. And this is because our XYZ parameters that sit in the position, I can move it in X and I can move it in Z because they're of Bezier float, and I can demonstrate this by moving it in Z and in X axis as well. But my Y is of type float reaction, and I can't move it left and right. What I've done here, and what I really love 3ds Max for, is that I can tie those parameters to be affected by other parameters of other objects. So for example, this robotic door can be opened by rotating this valve in the X direction. So if I zoom in closer and rotate it around the X axis, that is this one, the red one, if I rotate around it clockwise or counterclockwise in my option, if I do so, you will see that the door opens. First the bars, and then the door. And if I rotate to the other side, you'll see the change once again, and then the bars close. What I've done here is I've tied 5 of the objects, 2 of which are bars on the front, and also the bars on the back, and 2 of the doors, so it's 6 objects actually. I've tied their parameters, the Y parameters, those ones, of each object, and I've tied them to the rotation, the X rotation here. Once again, if we go into, for example, door, one of the doors, you're going to see the same exact picture as for the bars. If we open up the rotation, you can see that the Bezier type is on each of the X rotation, Y rotation, Z rotation, on each of the rotation types. But for position, only 2 of them are of Bezier type, X and Z. The Y position has actually this red thumbnail, signifying that it was tied to some other parameter. If you don't want to have this relation and rather want to move the object freely on the Y axis, if you want to remove the relationship of the valve to the front door, for example, you can go into the front door, open up the transform, find the position Y parameter, take out the float reaction controller by simply selecting Y position, going over here, assign controller, then select Bezier float, for example. And now all of them are of type Bezier float, and of course, as you can guess, I can move it in Y direction once again, or in any direction I want to, because it's unlinked in some way from this valve. It's different from linkage using this tool. It's different from locking in the hierarchy panel. It's something very different. It's tying the parameters of one object to the parameters of another one. This is a very important part that you should understand and will have to understand before you get into rigging. Because, for example, some people that were doing something with biped were trying to rig a character and it might have worked, but really biped or cat they aren't a way to go. You want to build a custom rig, for example, for a character who has 4 arms. The biped wouldn't suit because this is a representation of a pure human. For a dog, for example, you can't use biped. Yes, biped is a very flexible structure, but really, if you get into professional rigging, you don't want to be using one of those options. You want to be going for custom rigs built with bones, and you want to build a very responsive rig so that if you move, for example, an arm, a shoulder moves, and this is done with different options that 3ds Max provides, such as constraints in animations, IK solvers, and also wiring of parameters as well. In fact, if I switch to this dummy object, which is a point helper for me, I can even have a modifier which will be carrying all the different settings. As you might have guessed, I've linked the parameters of this dummy object, the rotate one to be specific, to the parameters of this valve. If I go into motion panel, since it's wired already, you will see that the X rotation is of type float reaction because it's tied to the dummy object. So I switch back to dummy object, go into here, into modify panel, because the dummy object carries a modifier, which in turn contains an attribute, by altering which I can rotate the valve in the way I want. So I still have the dummy selected. If I change the attribute, you will see that the valve rotates. Right now I've unlinked the door from the valve, so even rotating the valve from the dummy, doing this won't change the position of the door, but if I didn't do so, I would be able to change their position through changing the attributes value on this dummy object. So this would be rotating the valve, whose rotation is actually tied to affect the position of those bars and doors. There are several tools that will allow us to do this. Right now I would like to show you how you can change the position of the bars and the doors by changing the rotation of this valve. And then I will show you how you can add a specific parameter to the object and then make it affect some other object, our valve, for example. Right now all of my objects have clean values. Position is of type Bezier, and actually Y position should be of type Bezier as well. X, Y, Z position, they are all of type Bezier, and rotation is as well Bezier for all of the parts of my door. And for the valve, I would like to break the linkage between it and the dummy, so I'll select this float reaction and assign a controller of type Bezier, Bezier float, allowing myself to advance further. Also, a very important point is that even if you locked the position change here in hierarchy panel, even if you locked it on X, Y, Z, you'll still be able to move the object through the wired parameters. So for example, if your Y parameter is of type float reaction and is tied, for example, to the rotation of this valve, by rotating the valve you'll be able to move the object even if the object's move axes X, Y, Z are locked from moving externally by the user. Of course, same applies to a rotation or scale. Before doing any kind of reactions, you want to ensure that you've done the X form, reset X form on all of the objects that you are wiring between. And usually this is the process through which you would go before you would be doing standard linkage between objects, like this for example. So reset X form first, and then do all of kind of reactions, tie the parameters between each other and link the objects. But reset X form first, and then collapse the stack on your model, just like we did in previous tutorials. In this lesson I want to show you two approaches. You can use either wire parameters dialog, for example, that has this kind of look. Apart from that, there is also reaction manager, which hides in the animation rollout under the reaction manager name and has this kind of representation. You can expand all of the different sections in the way you want, and ideally if you have 2 or 3 monitors, you can stick this window onto a different screen and work on there and observe the changes that happens to the objects in your main window. Just like in the beginning of this lesson, there is a need to create a hotkey for your reaction manager, and I'll explain to you why you have to do this in a second. Go into customize, customize user interface, category animation tools, and find your reaction manager. My shortcut is Ctrl-R, and by pressing Ctrl-R with override toggle switched on, just like explained in the introduction of the video, this has to be pressed on. Ctrl-R will bring your reaction manager. Let's have a look at wiring parameters first. When we select cylinder and switch the representation of our transform gizmos to local for move, and if we press rotate and switch the representation to local once again, you can see that we can rotate around the X axis because we've hidden the other axes in the hierarchy panel. In fact, this is the exact purpose of checking those boxes. It simply hides the transform gizmo. Let's quickly switch to move panel, and we will be wiring the X rotation of the valve, which is of type Bezier float at the moment, to this bar to its Y position, which is right now of the type Bezier float, but soon it will be of type float reaction. Switch to the valve, right click on it, wire parameters. In this area you got 3 options available that you can see in this panel as well. You can go into Object Editable Poly and actually change the options of Editable Poly modifier, or you can go into Material, which is assigned to it at the moment, which is called 2 default, and you can work with different variables of the material. So if you would change something in the material, some kind of change will occur to some different objects. But right now we want to focus on transform. We want to affect the rotation, X rotation. Then you see this dotted line, which actually tells us that we have to link it to something. So we will drag it to this bar, left click. We want to affect transform, position, Y position. If I click on the bar, go into world representation of the gizmo, you can see that the Y is pointed to the left, X is pointed forward, and Z is pointed upwards. First, we selected our parent variable, which is rotation on this valve, the X rotation, that is the clockwise and counterclockwise rotation. And for the child variable, we selected the Y change of the bar that will be moving it left and right. Being in world, we can see that in Y it is 27 generic units, because I'm working with the generic units in here. It's not metric like it would be in Unity, it's just simply generic units. So it's 27 generic units along the Y axis. Of course, if I translate this model to the right, that would be a change, a negative change in Y, and if I would bring it to the left, that would be a positive change in Y. When I drag the spinner up and down, you will see that if I increase it upwards, doing a positive change, the bar moves to the left, just as predicted. If I move it downwards, the bar will move to the left. 0 point of Y is somewhere over this axis. If I right click on the spinner, that will zero out the variable for the Y, signifying that the 0 position on the Y axis of the world is over here. If I right click on all of them, I'll be able to bring this bar to the center of the grid, which is of course 0. However, I want to Ctrl Z everything, bring it back to its normal position. Getting back to our task, we are trying to wire the X rotation of our valve to the Y position of our bar. If we middle click on the screen, we can drag up and down, and right now if I shrink everything down and close up, you can see that we're looking at the cylinder, and we are also looking on the right on the bar. Actually it's Barker because I misspelled it, but we're looking at cylinder and Barker bot. When we open it up, we want to be tying transform, rotation, X rotation selected, and in Barker we want to be affecting transform, position, Y position. When we switch between objects, we can actually keep this window opened, but for example, if we decide to change the position to affect the value of this bar instead of this one, the window stays unupdated at the moment. And if we switch to a different bar, we can actually manually update it, either here or here, and that would plug the parameters of the object into one of the windows, depends where we update. Let's say we want to update on this window, and right now it's bar top. We can open it up, go into transform, position, Y position, and so now we'll be affecting the Y position of the bar through the X rotation variable of our cylinder. To do this, all we have to do is press this button, signifying that X rotation will be affecting something on the right, something selected on the right, or we can actually do it both ways. So if you change the Y position, for example, of this bar, something will happen to the rotation of this valve. Of course, you won't be able to do this manually because the controller type on the Y position will be of type float reaction, but you will be able to do it through some kind of other modifier, such as the custom attribute on the dummy object. This is something that might seem quite complicated, and it is actually. Wiring, animating the character, and actually skinning the character and modeling it, wiring a live mesh and interacting with different objects through changing parameters is one of the most difficult tasks in 3ds Max. A further final step would be doing it through scripting. We should be able to touch it once, but really just to create a custom parameter on the attribute with custom buttons. However, this will be further on, and you shouldn't worry about this right now. By the time we arrive to it, it's going to be quite easy for you to understand the flow. We want to be affecting the Y position of this bar top, so we'll be pressing this button. X rotation of our cylinder will be affecting the Y position of our bar top, so we can copy this variable of Y that is current to this bar, paste it in here, plus X rotation, so this value will be growing or shrinking, depends on which kind of rotation will be fed into it through the X rotation. But this is our starting point, and let's just increase the change by multiplying by 2. So the rotation of this cylinder will be doubled, and then this starting point will be added to it so that the change happens from over here. When you affect X, Y, Z positions, you are always working with the world representation, and you won't be working from local. So you might think that if we remove this, you'll be adding whatever the rotation feeds into this Y position, but it actually will jump to 0, and then from the 0 it will be counting wherever we want it to go. So we really need to fit this starting point so that the object remains in this place. The way 3ds Max works is it allows us to see the interpretation of world and local types of axes. But really what it's working with, what's working behind the scenes, is the gimbal. Rotating the object around one of its axes might affect other axes. It depends which rotation scheme you are following. Red one is X, green one is Y, blue one is Z. When in motion panel, in PRS parameters, if you go into rotation, you will see that the axis order is XYZ, meaning that if you are rotating around the X axis, you won't be changing the location and the rotation of other axes. But X holds on Y, and so if you'll be changing the rotation around the Y axis, you'll be flipping around the X axis, and Y in turn holds on Z. You can change different types of axes, but XYZ is usually the common one. So switch your interpretation to gimbal for the rotation and zero out the X value. That way, when you feed in the X rotation, in gimbal lock it's 0 and it's the true 0. So 0 over here as we start our valve, and this is the initial point, the position of our bar in the Y axis. I would like to prove my point that you can move different objects through wiring the parameters by switching to the local representation and simply hiding out the Y axis on this bar. If you still didn't notice, those parameters are different in local to the ones in world, because when you are working with local, you are working simply in absolute mode that allows you to add different values to different axis parameters. However, in world, or rather in gimbal, this is how the world perceives the position of this object truly. So we've locked the change in Y, which will be affected through X. We've zeroed out the X rotation in gimbal representation for the valve, and with the starting point when we connect it from left to right, you see that the Y position is now red and the X rotation is green, signifying that this is the parent variable and this is the child variable, which will be affected by the change in parent variable. When we switch to the motion panel, you will see that clicking on this bar, going into transform, position, Y position now has a float wire controller. And if we switch to valve, you'll see that the X rotation still remains as Bezier float, because we didn't affect it by anything. We can still freely rotate the object, but its rotation will be affecting the Y position of the bar. So Bezier float on the X axis and float wire on the Y axis in here. This is one approach of wiring different parameters, and as you could guess, you can tie all the different settings. You can actually tie the materials parameters. Right now it's a 2 default that is assigned over here by simply right-clicking wiring parameters, 0 to default, which is the current default material, and say glossiness. You won't be able to use ambient color because this is in the form of RGB, and this variable has 3 parameters, respectively for red, green and blue. Whereas Y position is a digit which can be positive or negative, but it doesn't have 3 parameters. So we can link glossiness, can be ranged from 0 to 100, link the glossiness to the similar parameter type of the bar, for example the transform, position and Y position. Glossiness plus the starting out point. Glossiness at the moment is 10, so let's bring it down to 0. Click on this arrow, connect, and your bar will be now connected to glossiness. If we increase the glossiness, the bar will move to the left, but it can't go negatively along the Y-axis because glossiness cannot be less than 0. The change is actually pretty small, and it's only visible within the object once we release the glossiness spinner. So we can click on it manually and see the change slowly happening, but it isn't once again really visible, so let's multiply the glossiness by 100 and update. If we zero it out, you'll see that the bar stays here, and if we left click above here and increase it by 1, you'll see that the bar changes. You might or might not be familiar with animation, but we will definitely cover it later in greater detail. However, for now, I'll just like to show you that you can simply animate a change in material that is going to be affecting our object over here. If you press N, that will bring you into auto key, meaning that you can drag the position of this slider to the right, for example, and on 10th frame, we would want to increase the specular level to, for example, 29. And what auto key does is it simply registers the change from the previous key. In this case there wasn't one, so it automatically picked up 0 and placed the key there. So change from 0 to the current position of the slider was recorded into the key on here. If we drag it to the side, for example, and don't do anything to our scene because this will plant another key for the object, but if we drag it to the right, you see that there are 2 keys, 1 and 2. And I actually realized that I changed specular level instead of glossiness, so I'll zero it out, and I noticed it because it was highlighted with red. That means that it's actually was animated and is present on the timeline. So for example, I can delete all the keys by selecting the keys and pressing delete, and now specular level is no longer highlighted. I will increase the glossiness to say 29 or 30, maybe 59, and once again it planted two keys, one over here and another one here at the 0. If you scroll back to the left, this is where we started out from, so if we put 0 in here, type in 0, drag it down or simply right click, this will zero out the glossiness on this first key because we are in auto key. It records any change you do in real time and records it into the current slot on the timeline. And if we drag through, you will see that the glossiness grows as we drag the slider to the right, to 21, 38, all the way up to 59. Even if we press N and deselect our auto key, this is still highlighted with red, signifying that it was animated on those two keys. It will not be highlighted as we scroll through the animation. For example, on the 5th keyframe you can't see it. However, when we reach its key, you'll see that it's highlighted with red. Of course, the change in glossiness calls for the change in the bar's position because it's tied to. If we want to remove this position, we would simply go into the bar, motion, find in the transform, Y position, select it and then assign a controller, Bezier float. This would remove the float wire, but we'll keep a new controller on top of that one. Right now I don't want to break any kind of links because I want to show you one final thing, that you can alter those parameters through the modifier on some object. If we bring the time slider to 0 and delete all of the keys, because we don't want to work with animations, we can create a dummy object, for example a helper such as this one, by going into create, helpers, and either create dummy or a point. Point is more flexible than dummy because we can change the size of the cube. Click on point, deselect cross, you can go into axis tripod, center marker, which is actually little cross which won't be changing its size as you zoom in or out, but we really need box, and you can actually combine them into different combinations. Box size of about 49, and then right click to get out of creation regime. With your point helper selected, let's go into its modify panel, then click in modify list, select attribute holder. This is an empty modifier which allows you to stack your own parameters and variables into the list over here. You can of course switch to point helper and change all of kinds of settings for this point helper, but right now we want to stay in attribute holder. Another very useful shortcut, and it might seem quite overwhelming so far because there are so many hotkeys, but one more useful thing is the parameter editor window, which you'll require in a second. It should be tied to Alt 1, and you can do it by going into customize, once again user interface, and I don't really know under which category it sits, so I'll press P and find parameter editor from there. Parameter wiring dialog and parameter editor above it. It should be set to Alt 1. With this done, you want to select your point helper, which has attribute holder ready for you to use. Press Alt 1, and this is a window that allows you to create custom variables and stick them onto here once again. Those are the two buttons that allow you to stick or alter the current parameter in here. We want to create a float type. Float is simply a number with dot with decimal, so like 1.55 is a float, as opposed to integer, which represents single increments by 1. It can be negative or positive, but really we want to go for float at the moment, because we want a smooth transition of position. So float, we can create either spinner, which is similar to here, or we can go for slider. Slider is less common because you can't really zero it out correctly, and you won't be able to type in numbers, but for this sake just select slider and call the parameter valve rotation. Our slider's width relative to this interface should be about 160. We can go for 100 and then it's going to be shorter, so let's go for 100, really for aesthetic look. From 0 to 100, let's set it from -10 to 10, and it should be at 0 by default. Alignment should be set to the right, for example, and offset 0 because it should be stuck just to the right side of this panel. So let's increase the number of ticks, and you'll be able to see the ticks. So this would be 0, this should be 5, 10, -5, -10 respectively. You can also go for vertical. This would change the representation of your scroll to vertical, of course. I want to switch it off for now and stick with horizontal. After this is ready, we got our width from and to, default is 0, right. We have 4 ticks, called valve rotation, of type slider can be spinner, of type float. After this, we want to add it to the selected object's current modifier, because if you select base level, for example, you'll be sticking your attribute to editable poly, if this would be a different object with editable poly, but right now it's point helper. However, for now, we want to select current modifier, so we'll be sticking it to attribute holder, although we could do it on point helper as well. After this, press add. This created a valve rotation attribute, which although doesn't do anything at the moment, it's simply an empty handle. Of course, you're already familiar with wiring the parameters, so you already know that you'll be accessing the parameter of this object, which is a valve rotation. Then you would be tying it to different objects parameters such as position, rotation, what have you. If you of course did a mistake in here, you can press once again Alt-1, bring up your parameter editor, which is always accessible in animation parameter editor. Selected object's current modifier because this is the one that you want to be altering. If we did some kind of mistake, go into edit delete, it will detect that it has a valve rotation attribute of type slider, and as we select it, you will see the change in here. When you have different modifiers or different attributes in this modifier altogether, switching between them will be a clear change because each one will have different options tied with them. So for example, we want to align it to the left. Click left with the valve rotation and then click apply changes. After this, you want to press accept parameter changes, and then you'll be able to switch to different variable if you had some of them over there. Close this window, and with your point helper selected, which has a attribute holder with a custom attribute of type valve rotation, select the point helper and right click, wire parameters, modified object, because we work with transform which has all of those different options, but for now it's modified object since it's modifiers, attribute holder, which is our modifier, custom attribute, valve rotation. We could actually work with point helper object if we would want to rely on the change within the point helper modifier's change of attributes, but right now attribute holder, custom attributes, valve rotation, and it awaits us to drag on some other object. Holding the middle mouse button, I will drag the camera viewport to the left. When clicking on the valve, you will be able to select transform, rotation, X rotation. And now we have this wire parameter dialog, which in fact is always accessible through animation, wire parameters dialog. You don't have to be clicking on the object, right clicking and dragging left and right. You can simply bring up your window, select some different objects and refresh the respective window, then go down to their parameters and wire them together. But right now we have our parameter wiring dialog opened for us, and we already have our valve rotation attribute selected on this point helper, and also we are ready to tweak the X rotation of our cylinder. Click on the valve once again. In the gimbal rotation, ensure that the X is zeroed out, and then we can simply say valve rotation, which is at 0 at the moment, and connect. Now our X rotation of this valve is tied to the valve rotation over here, and a change in this attribute will affect the rotation of this valve. So for example, dragging it to the right will rotate our valve to the right, dragging to the left will of course rotate it to the left. If you want it to be slower, of course put a slash, which is divide, and for example 4, update. When you drag this attribute to the right, the valve now rotates smoother. However, I don't really know the relation between the digits and the rotation in gimbal, because I'm thinking that an increment by 1 should have changed the rotation of this valve by 360 degrees, that is the full turn. However, it doesn't turn out to be so. So I don't really know the relation between the increase in digit that is affecting the rotation of this object, at least in parameter wiring. Because this bar's position, the Y position, is tied to the change in its material, it doesn't have the relation anymore with this valve. But if it had one, then by changing the attribute on this helper and rotating the valve's X rotation would be changed, therefore affecting the position of this bar in here. Parameter wiring allows you to use different formulas if you are good with maths. However, it's usually not a very good option when you want to restrict the movement or rotation of different objects. For that, you wouldn't be using parameter wiring. Instead, you would be using a different option, which is accessible by pressing Ctrl R, your shortcut for Reaction Manager that you've set up before. So pressing Ctrl R will bring up the Reaction Manager, which is the second option we want to look at. As I said before, with it you are able to restrict the motion or change in some different parameters and not allow them to go beyond some value in a different parameter that you are changing. I would be able to rotate this valve infinitely if it wouldn't be wired to anything else. And this beam would go infinitely to the respectful direction. Wouldn't be blocked because it would be wired with the wire parameters dialog. However, it's not the case with Reaction Manager. Let's go and clean up our transform variables for both the bar and the valve. Click on the bar, select the motion panel, go into transform position and Y position and get rid of float wire controller, get into Bezier float. Do the same for the valve. In this case it's X rotation because it's tied to this helper in here. Assign controller, Bezier float. Now you're able to rotate it freely and move this thing as well in any direction you want to. Of course, in here I can't move it because it's obviously locked in the hierarchy. Yes, exactly for the Y. And although it was locked in Y before, it will still be moving left and right along the Y-axis as we change the material's glossiness. A proof to my statement that you can move an object through parameters even if it has a lock on its moving axis. Locking this simply hides the axis transform gizmo. After we've cleaned up our transform parameters, we are now able to use the Reaction Manager. You can see the reactions option in here, which will show all of the reactions for all different objects. And we also are able, by clicking on different reactions in here, we are able to see the more detailed data that happens in different states of those objects. For example, we can click on this valve in here, click on Add Master, and then left click on this valve, transform, rotation, X rotation. This will be the parameter by changing which we will be affecting something else. With cylinder 01 selected, and actually 0.01 shouldn't be there, I'll click on here, delete selected. But with the cylinder selected, we can go here, add slave, or actually we can select all the things that we want to be affecting and click on add selected. Go into transform, position, Y position. And so you can see in the reactions, your cylinder, its X rotation to be specific, affects Barker bot, Y position, and Barker top's Y position as well. Although their pivots point are looking in different direction, you can see this in local. So this one looks to the left and this one looks to the right. You're always working with gimbal, so don't forget this. Gimbal, and you can see that the representation is exactly the same because you're looking from the eyes of the world at this object. You are affecting with the cylinder's X rotation, you're affecting Y position of Barker bot, and you're affecting the Y position of bar top as well. Having the cylinder selected, you can go into state. And state 01 is that you have this current rotation, which is 141 degrees along the X-axis, because you're working with X. 143. With the cylinder 01 selected, you can go into states and examine it further. You have right now only one state, which is affecting Barker bot and top. State 01 says that it has 143 degrees value, that is 143 degrees value for the X rotation. And respective position of Barker bot is 27 units along the Y-axis, and the current position of Barker top, the Y position, is 21 units at the moment, with this value of rotation, X rotation for cylinder. We can add another state by clicking here, and this is our state number 2. And for example, let's say when this valve is rotated for about 500 degrees in the X-axis, then Barker bot should be at 100, and Barker top should be at about -60. If we expand this window to be larger, you can see that I can change the window size and the window size in here as well. I want to decrease the scale, the vertical scale on this graph editor in here by clicking on this button and simply left click and dragging. I can middle mouse click and drag the window left and right, up and down, and actually it's too big in horizontal direction, so I'll click on the horizontal change and left click and left drag. You can see that the positive change is clearly a 1 for Barker bot, and you can see it's going from 27 all the way to 100 as you increase the degrees number. Similar stuff happens for bar top, but in a different direction because it's going to the right negatively from 21 down to -60. If you want, you can actually click here and add a point to one of your graphs. So for example, you can say 1 here and then click on here and move your point downwards like this. With it, your bar will be going to the right quicker. However, once it reaches this point, from now on it's going to move to the right slower, at a slower rate. If you don't like this abrupt change in the speed, you can right click on the point and set Bezier smooth. Then you can click on the tangents and change the curve's smoothness. by dragging out inwards and actually changing the rotation of this thing. So you can either have it really quickly going down, then slowing down for a moment, actually increasing the position by a tiny amount over here, increasing it further on, so moving it to the left, and then continue moving it down to the right negatively. But I want it to be smooth change. When I switch to my cylinder and go into rotation, when I rotate it, you can see that this bar on the right speeds up and then slows down as it comes to the right. I can actually animate this change, so I'll press N to go into auto key and maybe move my reaction manager to some other place. I want to animate the change in this valve's rotation. But actually right now we're at the final point, because this is the final point once the door is opened. We want to start from the doors closed. So I'll bring the time slider to the right and right click and actually set the key for position, rotation or scale. In my case it should be just rotation. Over on key number 20, press OK. We want to bring our time slider down to the left and then rotate our valve on the key 0 to about 200, minus 200, like this. And because we did so in auto key, the change was automatically recorded into the first frame. If I press play right now, there are only 20 frames to observe, so the change will happen really quickly. I want to go into here and change the playback speed to 1/4, so it's going to be 4 times slower than normal. You can either click here for play animation, or usually I'm using the buttons after B and M. There is a triangular arrow to the left. After this there is a triangular arrow to the right, and then there's a slash or a question mark, and this is the button you are looking for. This is the play in 3ds Max. So click on it next to the right shift, click on it, and you'll see the change. Because we have an empty area over here, I don't want to wait until it goes to the end and then switches to start again. Instead, I want to shorten out my timeline, and I can do it by either going over here once again and changing the start time and the end time, but I'm going to Control Alt and right click on the timeline and drag it to the right. If I would Control Alt left click, I'll be changing the borderline on the left side. And if I would click Control Alt middle, I'll be able to slide along my timeline like this. And so now we can press play and observe the change. So our bar speeds up and then slows down at the end. A further step in which we'll look at greater detail is that for each object there is a much deeper representation of animation state it's in at the moment. To see it, you can either select an object and right click and go into Curve Editor, or simply click on this button in here, which will bring up the window for altering curves for the different object. You are already familiar with different kind of parameters in transform, so for example position or rotation. You already know that object is controlled by X, Y, Z variables. And over here, if you click on Y, for example, you can see that from frame 0 all the way to the frame number 20, you see that this gradual change occurs in your bar. If we look at the bottom beam's position, the Y position, you can see that it adds up value on the Y axis and it smooths in and smooths out. Although in Reaction Manager, the bottom beam should have been a straight increase without any kind of curves. You can change the curve smoothness. For example, if you have 2 points over here and you drag this one down, for example like this, and this one you bring it up like so. Control Alt middle mouse button to zoom the way you want to. If I bring this key even more down, on the curve editor you see that it smooths in at the start. In this area it's an abrupt change, same as in there. To create a smooth curve, you would have to right click on this key and set Bezier Smooth. Then you'll be able to change the smoothness like I told you before. You can also go on Bezier Corner and then you can change different halves to the way you desire. Like for example an ease out, but a straight change as we go further in rotation of our cylinder. Because we rotated on the timeline, we can see the change in the curve editor in here. To clear the situation up, we have several objects. We got our valve in here, and we look at its rotation. We also have a bar whose position we are controlling, which moves along the y-axis. This is a positive change, and when it moves over here, it's a negative change in y. In here we're saying that we're controlling our cylinder, and it's going to affect two bars. The top one over here and the bottom one in here. So first one and then the second one. We're saying that as we rotate the cylinder, this value of 143 will cause the changes to the two bars to be of this type. And this is actually the initial position, because this is the initial rotation. Then we're saying that this rotation of 400 degrees will cause this change in the bars, this one and this one. And finally, as we go further, we have two more states, state 3, state 4, which is called state 9, and state 10, for example, which also causes some change to the bar or to some other objects. In our case, it's bars all the way. We're always changing their y positions on both of the bars. So y position over here and here as well. And we're looking at x rotation of the cylinder. However, after this, we've done some little animation in here. We've said that we want to rotate our valve by some amount along the x-axis, and we've recorded this change from 0 to 20. This is why we can see on the curve editor this kind of curve for the y position of the bars, because they are being affected as this thing is animated. And we see a portion of this curve that is displayed in our reaction manager. This is because while animating our valve, we didn't rotate it to the full extent. This is why we didn't get some of the values, the y values on the beams. And that's why we see portion of this graph similar to this one. Taking a look at this bottom bar in here, this is its curve, because it's bar bottom, it has this kind of curve. And if we say that we want a straight transition like this and a smooth one over here, that means that as we rotate our valve, the change in the position will be first smooth and then it's going to be thrown to the left in a positive direction in y-axis. It is similar over here on the graph as well. However, here it should be a straight transition without any kind of smooth. Here in curve, you are seeing that the bar is translated smoothly. If this wouldn't be a float reaction controller, you would actually be able to click on the keys if there would be some, and then go and change the tangents position and get rid of this smoothing in. However, because this is an external controller, you're not given those options and you can't set the tangents curve in the curve editor. Here in the beginning and the end keys, it doesn't matter whether you state that it should be a corner or Bezier corner, the ease in is still going to occur. If later on I'll find a solution to this problem, at this point you will see an annotation to the video. However, currently I don't know the solution to this, and we always will have this smoothing out curve. There is a way around this. You can set up the first point to be outside of the boundaries of the rotation that you're going to be using. However, this is a very rough way out, but it's still working. So we've looked at two ways of wiring the parameters of two objects. Now we know how to use the wire parameters dialog. We know that it allows us to create relations that aren't bound to any borders, so no boundaries. Also, we've discussed how to use the reaction manager, which allows us to create borders, so with boundaries. We now also know how to stick a custom attribute onto the object and then tie it so that it affects other parameters of different objects, so a custom attribute. And finally, we've just had a glance at the curve editor. If you are still wondering how I did this gradual opening of the door in the beginning of the lesson, it's simply because using the reaction manager I've created different states and I was affecting 6 objects at once with the rotation of the valve. As this rotation was increased, in further states the objects began to be affected by it. So until, for example, state 2, the main door wouldn't be affected by anything. As the rotation value would be grown in states, the value for position of the door would be the same in both of the states, and then the beam's position would be exactly the same as the valve gets rotated, but then the doors would start to change along the different states. And then simply I would grab the valve, animate the full range that was described in the reaction manager, and the door would open gradually. I wouldn't be able to do this with a parameter wiring dialog because it wouldn't be allowing me to stop the affected objects, since once again I would have to somehow detect when the valve reached some kind of critical rotation and then the bar should stop. But the parameter wiring dialog doesn't understand this, as opposed to reaction manager. Finally, one more thing that I forgot to tell you: if you are using a 3ds Max before 2013 version, it might be buggy, so you have to open it and close it every time you do a change in it. So for example, writing different parameters or states value, you'd have to close it and open it again by going into animation and reaction manager. However, because we've set up our short key, now you can simply press Ctrl R and bring it to front. Ctrl R, simple. In this lesson you got familiar with the parameter wiring. You understood that all of the objects have different parameters and variables such as position, rotation and scale that are stored in the transform. each one of which has a different controller that can be assigned to it. By affecting those controllers, you are able to inflict changes to different objects and tie their parameters amongst each other. You also know how to create a custom attribute, a custom modifier, with your own tweakable variable, and then you can tie this variable to be affecting position, rotation, or even the material's glossiness. We've done this using two tools, Reaction Manager and Parameter Wiring Dialog, and we've also had a glance at the Curve Editor, but we will be looking at it later on when we will be making a custom rig for the character. You also know how to lock the object's position so that you can't move it left and right, as well as that you were introduced to a new representation of the axis, the gimbal representation, a different one to world or local. This is another model that I've created, and it's a part of a robot. It's of course a leg, its limb that is going to be crawling with, and really it consists of several parts. Here is the left one, and if I move it aside you'll see what I'm talking about. And here is another half. This is how they fit. And actually, this is a mirrored copy of the left part. Of course, before mirroring this side, I've unwrapped this one, and so after this one was mirrored, the unwrap UVW layout remained the same for the new part. It is not super efficient in terms of polygon count, but this one is going to be used in animation for my project in university. Here you can see which kind of topology I'm following, and it's fairly well modeled. I've done some of the smoothing groups on the front part, on the sides, and on the inside of the part, just to give this nice smooth transition of lighting on different sides. However, because I've prepared my unwrap UVW on the left side before mirroring it to the right side into the second half, because I've done this unwrap UVW, it is present over here as well now. And when texturing this part, I can simply duplicate this texture in here, because the UV layout is going to be exactly the same as of its parent part. It's not going to be mirrored like the part is. If I go out of the expert mode and assign an unwrap UVW modifier, you will see what I'm talking about. Open UV editor, quickly turn off all of the unnecessary settings, try to remember the position of those parts in here. Then after you've done this, after you've taken a look at the left side, we're gonna go and switch to the mirrored part. Get out of any kind of editing regime in unwrap UVW, switch to another part, unwrap UVW, open UV editor, do not show a map, and you will see that the parts are lying in exact same form. Of course, following the principle of the fourth tutorial, I'm going to use one texture for all of the parts of this leg. Maybe the calves as well, if you can call them like that, the robotic parts of the leg, the other ones. They are all gonna go into here and here. Perhaps I'll be able to assign the part of the texture to some other meshes. If I open up the material editor and quickly assign our material to one of the legs, click in here to display the map in the viewport, you will see that I've done pretty good unwrapping and the texture isn't very distorted when you look at it. You can see several of the distortions. That's because of the sharp sides. As a rule of thumb, just figure out how your model is going to be unfolded and where you should position the seams. Because if you position them incorrectly, there will be no other way of laying out your texture other than making it to be distorted, since it's going to be trying to equalize itself on all of the sides. For instance, the front part and then the sides that come in here. Observe how I've placed the seams. They're going in kind of zigzag form, like this, like so, and then a couple of seams in here. And then of course in here you can see that the side is going like this. And this is a 90-degree angle towards this part. This approach allows me to fuse the front part and the sides as well into one single patch. But of course I'm breaking them up into two parts. For example, in here this side is allocated to this part, whereas this patch is located to the front part. If I would place my seam like this, making it take the front part and the side, that means when pelting you would try to stretch out this part, which is a side one, this one, and this one into one surface. And if I show it to you how it would look approximately, here is your front part, this is the side, the red part in here, and here is the green part. Really, this is a square polygon in here, and this one is as well. That's why they are bent at a 90 degrees angle, because they're square polygons. However, when representing this on a flat surface, the UV editor, there is not enough space for those parts to unfold correctly. And so this would result in a bending of your front part like this, in order to free up some of the space, both for the red and the green part. And that's exactly the case what would happen if I would place a orange seam like so. in here. But because I'm splitting my part into two parts, here you can see that this is the side, which has little tail, and if it's going to be unfolded in a 2D space like the UV editor, it's simply going to be able to be flipped upwards like this, and it's going to line up correctly like so with this part. And then this side and the whole of the back part is going to be unfolded in this fashion. 1 and 2. Here is 1 and here is number 2. And since number 1 and number 3 are split into two different parts and belong to different parts, that way we are able to separate them and avoid clash of those two parts, part 3 and part 1, when they're going to be trying to be unfolded when we're going to be doing the pelt. In this fraction of tutorial, I'll finish up talking about texturing, because we've already covered most of the basics, and I just want to show you different approaches that people are taking when texturing their work. So far we've been working with 3ds Max and Photoshop. We can either choose it to keep it that way, or go in a different direction that you actually might find out to be significantly easier. The most basic approach that we've taken is 3ds Max, and in Photoshop we really created the texture. That's where our texture was developed. It was made from the very beginning, from zero, but it has several drawbacks, one of which is it's very hard to control those transitions that occur on the seams. This is exactly why artists are trying to position their seams in hidden places, because the transition of texture on the parts where the seams are located is very likely to be distorted or not aligned correctly, causing this feeling of unnatural and low quality work. If we take a second approach, this problem is going to disappear from your list, because you're going to be drawing straight on the model. Even though your UV layout consists of several parts, because you're going to be drawing straight on the 3D model, you won't have to worry about joining of your patches on the seams and ensuring that your texture is symmetrical and equal on the seams. You know that there is a seam in here, but when I'm going to be painting on top of the model, like this, the program will do all the work for you and will record that the black lines should be going, for example, in here on the front part, like this, and then on the side part, which is this one, for example, the black lines should be going like this, etc. It's gonna be done behind the scenes for you, so you just have to worry about drawing correctly on the model itself. For that, just like I've explained to you before, you need to export a clean model in an OBJ format. So select your model after collapsing all the stacks and checking the scale, then reset XForm, collapsing once again. Of course, check that your pivot point is somewhere close to the model, otherwise when you import it to the package, your part might disappear because this pivot is going to be centered in the world. Ensure that the pivot stays next to the model, reset XForm, select your model, click on the Max logo, hover on this area, do not click it, export selected in the OBJ format. Call it something sensible, for example, robot claw, texture, please, and export it somewhere where it's going to be easy for you to find. In my case, straight on the desktop. From the presets, select ZBrush, that's the program where we're going to be drawing our texture on top of our model, and export. When in ZBrush, a very useful trick is, when we close the lightbox, is that we can go to Document and resize the size of our canvas, the working space, by simply dragging the slider to the right, for example to this size, and then click and resize. Confirm, and we have our space maximized in the viewport. That's going to import and import our OBJ object from 3ds Max. As soon as we do it, it's stored in our tools. Let's click on it, select it, left click and drag, press T and Q, following the principle of the third tutorial, left click and rotate around, maybe press Shift F and observe how simple the wireframe is. Right now it's only 200 polygons, a very small amount. In order to be able to draw on top of the surface, the object has to have much more subdivisions. Think of them as of pixels on a 3D surface. For that we can go into geometry and take out the smoothing option, because if with it, when pressing divide or simply Ctrl D, when smoothing out the object it's gonna get rounded, and we don't want this. So unclick the smoothing option, divide it several times, in my case about 6 times, up to this amount. Then click delete lower, and you will see that your wireframe, the lower levels, are baked into this model, and now the only thing you are working with is the highest level of division. What we're trying to come out with is a solid flat texture that we're gonna extract from the painting over this model, and we're not gonna care about polygon count on this new object because we're going to discard it later. However, because we've subdivided the object into so many polygons, now the texture that we're gonna put on it is gonna be much more detailed. We're gonna work with polydraw and the spotlight, Spotlight is a special add-on for the ZBrush, which allows us to project the texture from our viewport straight onto the object. And so turn off your polyframe. In Photoshop, prepare a texture palette, a collage of textures that you're going to be projecting from onto this model. In my case, I'm going to go into texture and import one. Then clicking once again over here, I'm going to select from the texture menu our texture palette, and it's loaded into the texture slot right under the alpha, the brush's representation. Let's select from the alpha a square one, and finally coming back to texture once again, let's add this texture to the spotlight and ensure that it's turned on. After this, we need to close the lightbox. Then you see that the texture appeared right in front of the screen. To move it, left click and drag outside of the circle and position it the way you want to. You can also pin the spotlight by clicking here, left clicking inside of this orange circle and dragging your spotlight wherever you want it to be. Then turn off the option of pin spotlight. Also, when left click and dragging left and right with your mouse, you can scale the image accordingly in both directions. You can rotate it in the same manner, change the opacity of the image, tile in the horizontal direction or vertical one. You can look through all of the options if you wish. Also, there is clone, similar to clone stamp tool in Photoshop, smudge, contrast, saturation, hue, intensity or paint. And clone, for example, if you turn it on, it's going to be sampling from the orange circle. If you left click and drag, for example upwards, you'll see that we are sampling currently from here. However, when I release the left click, if I'm going to left click once again, you see that I returned back to the original orange circle. So the sampling spot doesn't move up or relative to the brush at all. As soon as you release the left click, it's going to return back to the orange circle. I'm going to Ctrl Z this 3 times because I think my texture is looking okay. You can also increase the intensity by left click and dragging on top of your texture, or pressing Alt and left clicking will darken the image or even like burn it. Do the same with hue or saturation, contrast. You can see the changes that occur to the texture once I'm doing this. And smudge will blur out the image in the areas which you're working with. Nudge is very similar to smudge, and it's simply going to work through the texture as if it was like water or some kind of porridge, distorting it slightly in the areas where your brush goes into. With nudge you can create those twirls on the surface of the texture. With control you can right click and rotate the image and scale it proportionally in the way away from the pivot point, which is the orange circle. So if you click, for instance, here, you'll be scaling horizontally relative to the orange circle. As opposed to right clicking in this area, then it's going to be regarded from the bottom of the image towards the orange thing. And once again, left click outside of the spotlight to reposition the texture in the way you want to. Once this is ready, you want to increase the spotlight radius, and that's the area that will be shown to you when painting on the model, notifying you which area you're about to approach. So in my case, I'm going to increase it to about quarter. Then press Z to hide your image, but it's still there. And if I move it around, because our spotlight is of quarter, you can see that the circle is pretty big. What we're going to be trying to do is trying to align this model so that it fits in the area where we want to sample from. We won't be moving the texture from left to right, it sticks to the screen. What we're doing is repositioning the model so that we can sample from the needed areas. And so I'm going to increase the brush size by pressing spacebar and increasing the draw size like this, and start projecting from our image somewhere on the model. I'm going to do this from the metallic area. You have to turn off the Z add, turn on the RBG, and switch the material for the object, for example for the chalk one. After this, scroll down into polypaint, colorize, and start painting on top of the surface of the model. I want the front part to be metallic and the back part to be of a dark color. Also, a very important thing is that you should be projecting the texture from a straight 90 degrees angle, looking from the top of the model. That's because if you are projecting from this kind of angle, your texture will get stretched, as you can see in this example. So draw from the top, and because of that, many of the artists prefer to work not in perspective, but in orthographic mode, like I do now. If you don't like this, however, you can switch to perspective, but watch out for this problem. As well as that, keep in mind that when you zoom in, you will be laying smaller details onto the texture. Because of that, your small parts, when you zoom out, might look odd and not fitting with the overall texture. So keep this in mind. To avoid this problem, you can simply press spacebar and decrease the brush size. That's going to allow you to focus on the neat areas, such as corners, for example, and avoid the problem of having different scales on the texture, which would occur if you would be zooming into it and then drawing without changing the brush size. When I'm done painting the front part, I want to ensure that the edges are textured correctly. That's because, as I explained before, because I was projecting the texture from the top, I might have touched them on the side and the texture could have been stretched on them. So with a smaller brush size, I'm going to redefine the edges. When my front part is done, I want to do the inside of this part. I'm going to press Z and readjust my spotlight to be somewhere higher and maybe have a greater scale. So I'm going to press Ctrl, right click and scale my image vertically. Then reposition it once again, left click and drag upwards. Press Z to turn it off or hide it. Shift Z to turn off the spotlight completely. You can always turn it back on by pressing Shift Z once again or going into texture and ensuring that it's on. So Shift Z and you can continue working. Finally, the holding part should be of this kind of texture. I find that the colors are way too bright, so I'm going to press V and switch black into my main slot. Maybe change its color to something grayer and maybe more brown. Intensity of about 70. I'm going to left click and drag out on top of my texture. Maybe with a different color, so black for the secondary or gray. V to switch it to the main slot. Change the alpha to be a smooth one with dots. I'm going to left click and start painting, probably with a smaller intensity. I'm going to paint on top of the model, where it's especially bright. With brush, it doesn't really matter from which angle you're looking at the model, because it's not a texture, it's a simple color. It's not going to be distorted. After this, I want to redefine the edges on some particular parts. So I will switch my black color for the primary one, and with intensity of about 80, I'm going to zoom to the model really close and start drawing on top to redefine its edges. If you find out that while drawing on top of the model, you are still affecting the sides, although you shouldn't have, if for example I'm drawing on the top right here, I'm going to turn my viewport to the side, you will see that I was affecting some of the polygons in here on the side, whereas it shouldn't have happened because I was drawing straight from the top. If you don't want this to happen, simply go into the brush, auto masking and backface mask. This works both for sculpting when you're working on very thin surfaces or for polygon drawing as well. Then, as you can see when drawing from the top, if I turn to the side, the result is completely different. We're not affecting the side at all. If you're afraid that you're going to touch some space behind the model, such as for example in here, and you don't want to affect this part, you can simply press Ctrl and mask out the area that you don't want to be affecting. Then paint on top of the model without worrying that you are going to affect the part from behind. Control left click outside and drag outside of the model. Get rid of your mask. And as you can see, I didn't affect it in any way. Don't forget to save your work as well. Make sure you save it as a document and as a tool as well from the Tools menu. Finally, when your texture is ready, let's close out any kind of rollouts and close our polypaint as well. Let's go into texture map, press new texture and click new from polypaint. If you hover on top of the image, you will see that we have our texture which is painted on top of our UV layout. I want to draw my name on top of this part, so I'll zoom in with color brown, lower opacity. I will turn off the texture, will lay down my name on top of the part. And maybe with a darker color, so press V into your main slot, switch the gray color. I'm going to outline slightly. Once again, I want to press Shift Z, and with my spotlight on, maybe with a smaller intensity and larger brush size, I want to just cover up my letters so that they appear like they have been indented into the surface. Clone the texture, and from the texture palette, with it selected, let's go ahead and export. You can export as a bitmap or TIFF, but we're gonna go for Photoshop under the name Robot Claw Diffuse. If you want to save your project and close the ZBrush. When done, drag the file into the working area of Photoshop and notice that it has been flipped upside down. If you remember, the direction of our UV was from bottom right corner upwards to the left, and right now it's like this. So all we need to do is double click on the background to make it a layer, press Ctrl A, then Ctrl T, right click and flip vertical. This is a standard procedure after you've been working in ZBrush. It is so because the axes are different. While the y-axis is common to be the up axis for most of the 3D packages, the upward axis is Z. After this, I simply want to zoom in, apply a transformation, and after this I want to go into my burn tool with exposure of 20%. I'm going to inflict this new exposure onto my name, simply burning into the surface. Also with the sponge tool, I want to desaturate it from the current color. Watch out so that you don't work near the edges, because that's exactly what we've been trying to avoid while working with ZBrush. Also, I find that this area is too bright. I will select my burn tool and will burn shadow. I think that in overall it's too bright or maybe too saturated. So I'll press Ctrl U, and if you would press Ctrl Shift U, you would simply desaturate the whole image. But Ctrl U allows you to bring this window in which you can adjust the saturation to the desired level. Maybe go into Image, Adjustments, and Curves, and tweak the curves, adding a few keys here and there. When you think you're ready, click File, Save As, or simply press Ctrl-Shift-S, and save it in a JPEG format. Robot Claw Diffuse JPEG, and for my robot leg, keep in mind that I'm going to stick more parts in here, so we're not only texturing the leg. So the texture file should be pretty big, but reasonably big. So for example, for leg and couple of other parts, I could afford 400k for the game, maybe 600k for the animation if it's a main character. As I'm entering the program, you can observe that the leg is actually a part of the robot, and it has 3 of them in its body. The leg is actually parameter wired, but we'll talk about this a little bit later. All that it means is that I can manipulate the position of the leg by changing some kind of parameter within different object. For example, tweaking this parameter will open or close the leg, depending on value in this area. If I select the leg, press M for my materials, pick an empty material slot, call it leg material, press enter. I can go into maps. For my diffuse color, click on none, pick bitmap, go out and select the texture from the place where we saved it. It was our robot claw diffuse. You can view the image to verify that it's the right one, or you can click in here and pick a different image if you want so. After you're done, let's go back by pressing here to view the texture on our model, show shaded material in Viewport. If you recall, because we've turned our texture upside down in Photoshop, it aligns correctly with the UV of this model in 3ds Max. But you might have forgotten to flip it upside down, and then you would see a strange anomaly where the texture wouldn't fit at all because it would be flipped upside down from ZBrush. Let's assign the same material to the other leg, and since it has exactly the same UV layout as the left leg, but is mirrored, my name on top of it is going to be mirrored as well. Igor here and Rogi here. However, that's not everything that we can do. I just want to show you what is your alternative to using ZBrush, like we did a moment ago, what you can do if you don't have this tool. Since 3ds Max 2011, and this is 2013 already, we can basically do the same thing as ZBrush provided us, which actually is not a very big simplification from ZBrush. Let's go into Tools and click on the Viewport canvas. As you can see, this brings us a window with different brushes and options that we can click. We can dock it anywhere, but I really prefer to have it somewhere next to me. To start drawing, we need to select an object, for example this left leg. Let's press Alt-Q to isolate it and focus on it by pressing Z. As we click on the brush, we'll be asked to which slot we want to color it on. Let's paint straight on our texture. After this is done, we have something that reminds us a lot about the Photoshop layers. You can duplicate the layer, you can add a new layer or delete the existing one. Let's click Add New Layer. Of course, you're going to be drawing on top of this one. If you want to merge it at any time with the bottom one, simply right click on it and merge down. You can turn off the layer by clicking on the bulb, but for now keep it on. And with your primary color, for example golden one or a gray golden one with the radius of about 4 and opacity of 50%, I'm going to zoom to the model to be able to stylize my texture further. While working in this layer, you can always erase what you've drawn from the current layer, and also very importantly, you can clone stamp. This is exactly what you want to use to get rid of the seams if you have been using the Photoshop approach. To sample, simply Alt-click and start painting just like in Photoshop. Use this to get rid of any kind of seams, for example like on Widow in part 4. Simplify your life without having to worry about getting rid of those seams straight into Photoshop. Just bring your model here with the texture and paint on top of this texture where the seams don't line up. You can blur, sharpen, increase the contrast, dodge or burn. You can even do gradient if you want to. As you're working, you can always jump into 2D view and paint in there as well. If for some reason you don't see the layers, you can click into layers dialog and this will show it up. Finally, to finish the texturing, I want to point out that when unwrapping the model, there are actually several of the channels, up to 99, which you can have on the model, and you can use them to store different UV layouts on the same model. So for example, on map channel 1, if we open the UV editor, you can see that our UV is present in this formation. If we close this, switch to map channel 2, we're going to get this warning window that's going to ask us if we want to duplicate our UV layout to the second layer, or if we want to abandon it and work with the one that is stored on the level 2. Let's say we want to abandon it, not copy it from the first level to the second one. Abandon, open UV editor, and you can see that our UV layout on the level 2 is completely messed up because we didn't unwrap it ever for level 2. We could go for the same procedure and unwrap it, or simply go to level 1, save our UV layout somewhere, then go into level 2, abandon, and load our UV layout into level 2. That way we'll have two exactly the same UV layouts on two different channels. Those channels could be used for different purposes. You could be overlaying textures, such as light maps on top of diffuse, specular, whatever you want. And when doing normal maps, if we're talking about render to texture, you can see that here, for example when working in part 3 of my tutorials, we used existing channel. We didn't allow the program to re-unwrap the model because that would mess up our unwrap on the specific channel. But we said use existing channel from channel 1. If we would be baking a normal map from channel 2, we would get a completely different normal map that wouldn't actually fit to the channel 1, the standard channel of our model. When unwrapping, always work with map channel 1, at least for diffuse, and consider using channel 2 for light maps, shadow maps, or ambient occlusion maps. Of course, normals map isn't the only option. You can also do shadows map or light maps that are going to create a texture that can be overlaid on top of the diffuse in case if you have a light, for example, in your scene. You're going to bake this light into the texture. Then you can kill the light and your texture will still make an object look like it is lit by some kind of light, although there isn't one anymore. At the end of our lesson, I wanted to just quickly recap what we've done today. We looked at smoothing groups and how we can store UVs so that we can readjust the geometry of our model after we've unwrapped it. You now already know how to do unwrapping of symmetrical models in seconds, because now the mirrored part of UV coordinates do not have to be readjusted with our new strategy. With this tutorial, you figured out how to maximize the workspace of the viewport, how to remove the timeline, and you've got also a little introduction to macros. Now it is possible to use them, as well as add the shortcuts to your workflow. Today I've explained what the transforms of object are, as well as explain what parameter wiring is, that it goes along with mathematical formulas, versus wiring with boundaries that is done through Reaction Manager. You can now even tie the properties of materials and modifiers to the transforms, and vice versa. You can now force, for example, the object's opacity, or the R component specifically, in the objects to decrease, as he for instance gets moved, or the other model to which he is tied is experiencing some sort of change. Today there has been an introduction to the curve editor, a tool for simply adjusting the slopes, acceleration rates of parameters along a timeline. At the end we've looked at the addition to the Photoshop texturing approach, which allows to hide the seams through painting directly in 3ds Max. Now the texturing of our window can be complete and the seams won't be visible on the sides of the window under the armpits, or anywhere where our patches on the UV don't line up. Finally, we've looked at the new approach in painting directly in ZBrush, using which you can paint directly on 3D model and come out with a nice texture that can be then altered in Photoshop and then used in 3ds Max or any gaming package, for instance like in Unity. With this said, I just want to thank everybody for watching the tutorial. Merry Christmas and Happy New Year. The next one is probably going to be recorded in a month from now on. This is because I have to return back to university. I'll be having a rest for about a month or so. So I wish the same to all of you. Thank you for your support. Keep watching the tutorials, put a like and subscribe if you haven't done so already. My name is Igor Aherne and you have been watching part 5 of how to create a horror game. Thank you once again and I'm looking forward to seeing you. Goodbye.